We're now going to solve quadratic inequalities, and we're going to do this graphically. And so what we want to do is we're going to start with a quadratic inequality, such as x squared minus 4x minus 5, and that's greater than or equal to 0. And we want to know all of the x values that make this true. And the way we're going to do this is we're going to graph. And we're going to graph by properties, because this is in general form, not in transformational form. So we first find our h. h is minus b over 2a, which is minus and minus 4 over 2 times 1, which is positive 4 over 2, which is 2. We then find our k by plugging in the 2 that we just found to get 2 squared minus 4 times 2 minus 5. And we're cheating a little bit because we're saying this is f of x, and we want to know when is f of x greater than or equal to 0. That's why we can do this. We get 4 minus 8 minus 5, which is minus 4 minus 5, which is minus 9. So my vertex is at 2 minus 9. Okay. Now we need to find our y-intercept. And our y-intercept is going to be at 0 minus 5. And at its mirror value is going to be at 4 minus 5, because that's as far away from 2 as 0 is. So we just take that and double it to get that. Now this is important. We really need our x-intercepts. And I'll explain that once we have the graph. And so our x-intercepts, we take x squared minus 4x minus 5 and set that equal to 0. This factors as x minus 5, x plus 1. So x is 5 and x is minus 1. So we have a point at 5, 0 and a point at minus 1, 0. So now that we have our points that we need, we draw our graph. So we go over 2 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. And so there's our vertex. And notice it's below 0. This is our y equals 0 line. We then graph our other points. We get 0 minus 5, 8, 7, 6, 5. And it's also over at the same y value, but it's at 4, so it's 2 away here and 2 away here. And we get to draw our intercepts in, 1 here, 1 here. And so notice the basic shape of our graph is going to come from here, it's going to come up, and it's going to come up. But what I care about is when am I above this line? Because that's when my y value for my function is greater than or equal to 0. So I'm breaking my graph down into pieces. So I have these pieces here, the purple, which go up. That's not quite, there we go. That looks a little bit better. And we have the red underneath. And the question is, which of these is above the line? Well, when we look at the graph, it's very easy to see that it's the purple. This is everything here. So all of my x values going this way and this way are valid. So we go from, our answer is from minus infinity to, oh, what's that point? Hey, it's the x-intercept, minus 1. And it's a square bracket because it's an or equals. And we're going to start back up at 5, and we're going to go to infinity. So this is my answer for the greater than or equal, doing this method graphically so that we can get our answer and we can see it visually what's going on. But notice what's really important here is that it's the x-intercepts that matter. The x-intercepts, these two values that we found right here and here, are the boundary. And they show up as part of our answer.